Hi, thank you very much for dropping by at Telstra's IMS on AWS demo. And this demo is about how Telstra optimized resiliency of its existing IMS network by deploying CNCS, a cloud-native communication suite from Nokia on AWS. So IMS is the subcomponent of telecom networks that powers voice, such as whenever we use our cell phone for making ordinary voice calls or emergency calls. And it's very important to have resiliency of that network through different type of events, whether they are planned events such as maintenance activities or unplanned events such as outages. Customers or operators like Telstra wanted to make sure that there is no impact of these type of activities on customer services. So service continuity is very important for Telstra and other operators, and this is what they wanted to achieve in the demo. So basically, the objective of the project was to study and pilot how we can enhance resiliency of nationwide networks by deploying IMS on AWS. And to do that, the objective was to accomplish seamless service continuity for Telstra's consumers so that planned and unplanned activities don't interrupt availability of services to their consumers. One important goal that Telstra wanted to achieve from this project was to accelerate the deployment such that it doesn't take as much time as ordinary on-premises deployment of project at that scale takes. And I'll talk in my next upcoming slide about how much improvement Telstra achieved by using AWS managed services in this project. Next, I'll talk about the high-level architecture of this project. So briefly speaking, if you see from my right, Telstra deployed in AWS Sydney region, and there are two regions in Australia, one in Sydney and one in Melbourne. And here they're showing all of these managed services that was deployed by Telstra. So these managed services included compute, storage, as well as matrix. And then in the demo, I'll show you that how Telstra used these managed services to complete their deployment. And on this side, you see that Telstra used AWS's fully managed router product called Transit Gateway to accomplish connectivity with their on-premises network, because it was very important for Telstra to make sure that the AWS deployed network can continue to interoperate with their existing on-premises network. So by end of the project, there were two key goals that were accomplished. One was that the resiliency of the network was achieved, but at the same time, the deployment time took 50 to 75% improvement compared with like-to-like deployment on premises. And at the same time, they were able to achieve mean opinion score of 4.5. And mean opinion score is a KPI which is used to measure the quality of voice. And because we are talking about voice networks, it was very important for Telstra to achieve at least similar or higher quality of voice that their customers are used to from their on-premises network. And anywhere between 4 to 5, 5 being the highest, is considered very high mean opinion score. And by running completely in AWS region, Telstra was able to achieve 4.5 of mean opinion score. Here, what you are seeing is customer testimonial from VP of Telstra Network Application and Cloud, Shalin Sagal. And Shalin Sagal was very pleased with this project, especially because of the collaboration between AWS and Nokia for Telstra to achieve the resiliency from the AWS scale and the agility and cloud nativeness from Nokia's CNCS software. Next, I'll move on to showing you the demo. So the demo is going to be based on a video recording, and in this demo, basically, I'm going to show in 5 simple steps this deployment was accomplished. First step being setting resilient networks. Second step being resilient compute. Third step being monitoring of the infrastructure. Fourth step being the integration, and 5th step showing end-to-end automation. So here it is showing how to set up resilient network by using VPC. VPC is a regional level construct, and because it's a regional level construct, anything happening in particular availability zone does not have an impact on the rest of the deployment since they're isolated. As you can see that there are 54 different networks for O&M traffic, for media traffic, for signaling traffic were deployed. And because they were in different availability zones, one availability zone's impact is not going to impact another availability zone. For networking within AWS as well as with on-prem, we have a product called Transit Gateway, which is a fully managed product. So it scales up and down based on the customer traffic requirements, and customers don't have to maintain it. It's a fully managed service, and because of Transit Gateway, customers can control how they want to route traffic within or outside of AWS for a specific type of routing domains like O&M traffic. Here you are seeing the compute which was deployed on EKS. As you can see, it is based on more than 490, almost 500 microservices. And having a platform for this complex deployment, which is fully managed, is very important so that you can scale different microservices up and down on time. It was based on approximately 18 worker nodes, and those worker nodes are fully managed by a concept called managed node groups. So customers don't have to worry about replacing unhealthy fleet. We take care of it as a fully managed service. So what you're going to see now is AWS CloudWatch. And AWS CloudWatch is AWS fully managed service for reporting metrics and logs. As you can see here that there are metrics being reported for infrastructure like CPU utilization, for example, but you will also see application specific metrics like SIP registration. So applications can use CloudWatch agent to report all these metrics. And as a result of this, customers like Telstra don't have to bring in their own tooling, set it up and manage and scale. They can use AWS provided tooling as a fully managed service. Next, I'm going to show you some of the use cases that Telstra ran to validate this deployment. So basically, Telstra used VoLTE and voice over Wi-Fi use cases to verify the deployment. And as you can see here, that these are some of the use cases that Telstra executed, ranging from simple A to B calls to emergency calls, as well as to on-prem networks, and from on-prem networks to AWS-based network calls. And next, I'm going to show you some of the characteristics of the voice calls, such as mean opinion score that they achieve. So here, this is showing trace of one of the ordinary calls that Telstra made. And as you can see on this screen, I'm going to pause here now, that Telstra managed to achieve 4.13 and 4.15 of mean opinion score, which is considered pretty high for voice networks. And last but not the least, I'm going to show you a trace for another call, which is emergency call in this case, for which also Telstra was able to achieve very high mean opinion score and latency. I'm just going to display it. So as you can see here, they achieved 4.4 mean opinion score for emergency calls as well. So basically, just to sum up the demo, basically there are two takeaways from this. One is that from AWS fully managed compute, storage, and networking, automation tools, as well as monitoring services, Telstra was able to deploy what ordinarily takes 6 to 9 months in 2 months period. So more than 50 to 75% improvement, as well as at the same time, by deploying completely everything in AWS region, Telstra was able to achieve a very high 4.5 mean opinion score out of 5, which is considered a very good indicator of voice quality. This was a demo for Telstra IMS deployment using Nokia's CNCS on AWS. Thank you.